Hi, welcome back. In the video today, I would like to share with you how to solve this kind of trigonometric equation with general methods. So now let's get started. In the problem, we have a few parameters called A, B, C, and they are real numbers, and of course A and B have to be different from 0. If I equal to 0 or P equal to 0, that it become a very easy form of the equation. So we don't care about that kind of value. We care about the AB with non-zero numbers. So with A and B non-zero numbers, we have A multiply sine x plus P multiply cosine x equal to C. To solve this kind of equation, we remember the formula, the trigonometric formula that cosine x multiply cosine y plus sine x multiply sine y equal to cosine x minus y. So, and another trigonometry formula is we have any cosine y cosine square y plus sine square y equal to 1. So it means we have to transform a bit in this equation to make this become sine y and make this become cosine y. How to do that? And we don't know A and B are smaller than 1 or not, because sine and cosine function is always greater, it's always smaller or equal than 1 and greater or equal than -1. We don't know that about the parameter A and parameter B. We have to do a bit transformation, and the way we do that is we base on this one. From the asterisk, we can think about A square plus B square, and this would be greater than 0 because the condition at the beginning we have A and B is non-zero numbers. So A over square root A square plus B square on square plus B over square root of A square plus B square on square will equal to 1, because this is A square over A square plus B square over A square plus B square equal to A square plus B square over A square plus B square equal to 1. So that is matched with the asterisk. And you can see that this the A over square root of A square is always smaller than 1. And that is actual because this is smaller than a square plus b square. And because b is non-negative, non-zero number, it means this one would be greater than square root of a square, so it's greater or equal than absolute of a, and absolute of a is always greater or equal than a, so this is greater or greater than a. Similarly, for p over square root of a square plus b square. So now you see that it will match with the condition about the sine and cosine function. Now let's to put that as the a over square root of a square equal to sine k or sine y if you want to the same as the beginning, and p over square root of a over plus b square equal to cosine y. So then in the problem, we put it 1. In the problem, we just divided two sides of equation 2 square root of a square plus b square. So from 1, we will have a over square root of a square plus b square multiplied by sine x plus b over square root of a square plus b square multiply cosine x equal to c over the same things. So as the substitution variable here, sine y, we replace into the equation. We have sine y multiply sine x plus cosine y multiply cosine x equal to c over square root of a square plus b square. So, and in the trigonometric formula we have this. So just see that apply this formula and this will become, on the left hand side it will become cosine x plus minus y equal to sine equal to c over square root of a plus b. Now we have to check the condition of c. You know that cosine function is smaller than or equal than 1 and greater than or equal than negative 1. So if we have to check the domain of parameter c. So because when you see the problem that is very specific number, you can directly to put it and you can know that it in this in the middle of the negative 1 and positive 1 or not. But in this case we have to consider if c outside of this, so the equation will be impossible. It means there is no solution, no root of the equation. And in case the parameter c satisfies this condition, so it means we can convert it into cosine, another cosine value like cosine alpha. Then we let it as the cosine alpha. Then we have the root of this equation is x minus y equal to negative positive alpha plus k 2 pi, with k is a member of the integers. So then from this you see that y is the specific value you can find from this, and alpha is also specific value you find from this. So then you have the x value as the root of the trigonometric equation as the problem says. So the lesson from this is when you apply this method, you can solve a lot of problems with similar form as my problem, like this. And remember about apply the formula as a list on the screen. Cosine x, cosine y plus sine x, sine y equal to cosine x minus y, and cosine square x plus cosine square y, cosine square x equal to 1. And the most important thing about the condition of the sine x and sine y is smaller than 1 and greater than negative 1. That is the domain of the sine x and cosine x function. So I think it will help you in your examination, also in your math problem. Thanks for watching. See you later. Bye.